Hi. Um, Today I want to show you something about MultiMesh and GridMap in Godot 4.1 RC2. It's still about my Minecraft Voxel engine, and this is still a tech preview. And what I did here is I procedurally generated cells like in Minecraft. It's taken from a YouTube video from Henry Knieberg, and I first set the parameters in an editor for all the noise maps and load the configs in my Minecraft Voxel engine. And okay, what you see here is here are some numbers which describe how far the cells are calculated, and I prepared something for showing you that the sections I use for the Minecraft terrain are 16 by 16 and 80 cells high. And here on the right, this correlates to the three numbers in my script, which is this is a greatest radius, which means that here are the sections generated and are written on disk, and in this next radius these written data is loaded and instantiated into a 3D array and some assets as far as possible in Godot threads. And in the next radius, in the smallest radius here around the player, these Godot nodes are shown. Okay, and this, okay, I close it again. These are here the numbers. This means this is big in here. This is the largest radius for writing on disk, and it means the diameter is 10 multiplied by 2 plus 1, so it's 21. So, and this is the next smallest, and so on. And this means you have quite some cells to render. So if we look down here, this is the output from the last run of the game. So where I also used the MultiMesh approach. So we have over 1 million cells to render. This is pretty much. Okay, so all about here, assets are later. We have the sizes in my script. And I start here with the MultiMesh approach. So the terrain cells are rendered, the voxels, the cubes are rendered with the MultiMesh approach. And okay, it first has to generate and write a disk before starting at all. And while the engine is running, it will generate and save on disk on demand if the player moves. So it's nearly done. The first step, we see already something, but then we fall down to the terrace. This is something that has to be fixed. So we have to restart, and then we can check it out. I can already activate the frames per second. It's still very slow. Okay, it's really slow. It's interesting. Always something. Okay, now we're up. So before it is starting, it has to instantiate very much because nothing is there. And if we are moving, it always moves the radius and instantiated, generated, and so on demand. And what I want to show is that this is a multi-mesh approach. And always, so if it renders and shows, it's maybe still okay. Okay, it's not that much frames per second, could be more. But the point I want to show, what I want to make here, is that the problem is updating these sections. So because we can't hold all the sections and it's infinite terrain, we have to use something on demand. And you see, always if I move here, okay, if I run, that's more dramatic. You see in the output that it has to generate new sections. And my approach right now is to calculate the transform for the multi-mesh per section, save it there in the section, and then if some sections are created on demand, I have to add all those pre-calculated transforms together and set it to the multi-meshes. And okay, let's declare the numbers here. It's this TM, we can ignore. It is for the assets, for the trees, for the grass, and so on. It's currently only 4 type of asset objects on top of the cells. And okay, here's another update step. This means we completely or nearly use up the frame time for our transform update here. And of course, there are much cells. And then again, we still have to do 12 draw calls. So we have one draw call for all types of terrains of all instantiated sections right now. So for this number of dells, I would say it's not that good approach. But for things like trees or here or grass or something, it's pretty okay. So I want to compare this now to a GridMap approach or to the GridMap approach in my engine here. So there is one switch here. It's in terrain resources. Now if I change this, it uses a the GridMap approach, and not the multi-mesh approach. Fire up again. The pre-generation is not done anymore. It is already written onto disk. And okay, I have to activate the frames per second. Okay, so frames per seconds are a little bit higher, but I think it's okay, but it's not the point I want to make here. Because if I run here now, you see that it's fluent. So I don't have some stuttering or something like that. It's not that performant, okay, but the stuttering is gone, and that is what I realized from version 4.0 to 4.1. They improved updating those GridMap things, and that's very cool, I think. I think that's the main point here. In the past I always thought at GridMap for something that is okay, you can set up in the editor with some cells, so performance was okay. But I use GridMaps completely procedurally here. And if it's loaded on demand here, I add it to the scene tree, and it's fast enough now. It's very cool.